We're just going to talk about the fundamental facts of probability. Probability is a number between 0 and 1, or you can say 0 and 100%. It tells us how likely it is for an outcome to happen. To calculate the probability of an outcome occurring, here are your formula. One or the other, it's the same thing. Either you can consider them the number of successes, the number of results that you're looking for, the outcomes that you're looking for, divided by the total possibilities or the total number of outcomes. These are the same. This is very important. I even like to put probability of something is how many, or it's kind of like what you're looking for, how many of events of what you're looking for occur. Divided by your total possibilities, or just your total. Okay, we have P of X. Typically, we'll have P of something. Like P of 2 would be read, what is the probability of having an outcome that is equal to 2? With a die, it says, what's the probability of rolling a 2? If you're talking about heads or tails, you could have P of H. So if you flip a coin, what is the probability of getting a heads? Now, if I'm rolling a die, what is the probability of getting a 2? 1 in 6 is correct, right? We have 6 sides on a die. If I roll it, theoretically, each side has an equally likely chance to turn up. I'm looking for a 2. I only have 1 2. So I have one thing that I'm looking for. So the number of successes or the number of outcomes in the event, or what you're looking for, I only have one thing of it, the 2. Out of the total amount of possibilities, 6 sides on the die, which is why the probability of rolling a 2 is 1/6. 4. If you have a calculator, you can get one out. What I like to do is change these into decimals and change that decimal into a percent. Because I feel like with probability, it's easier to think of a percentage instead of a fraction for how likely something will happen. So 1/6 turns into 0.16667, or a 16.7% chance that I will roll a 2 when I roll a die. I lost. I wasn't in the 16.6% chance. Okay? You flip a coin. Aha. What's the probability of flipping and the coin landing in my hand as a heads? 1 out of 2, right? Why is that? Because I have one thing that I'm looking for, just a head on my coin, and I have 2 possibilities, a head or a tail. I got a tail. I lost. Okay? So, probability of rolling a heads, we would say, is 1 out of 2, or I have a 50% chance. Okay? Now, those are easy. It's only one option, right? But I could change something to be like, what is the probability of getting a 4 or higher? Or higher than 4. Why don't we say higher than 4? Right? What is that probability going to be? Doesn't include 4, just higher than 4 for rolling a die. It'd be 1 out of 3, or we have 2 possibilities that we're looking for on my die, a 5 and a 6. Those are my 2 possibilities. My total outcomes are still 6. 2 out of 6, which is 1/3, which is 0.3 or 33%. Okay? Those are simple. You just have one thing. Probability gets more difficult when we start rolling die multiple times or flipping coins multiple times. So I could ask you, what is the probability of rolling a number higher than a 4 2 times in a row? And all of a sudden things change because the total amount of outcomes change drastically. And we'll get into that in a little bit. Before we get into that, when we do things multiple times or when you have multiple options, like the probability of flipping a coin and it landing heads, and then the probability of rolling a die and it landing on a 1 or a 2, we'll get into that. But the key to probability in all situations is this law of large numbers. Law of large numbers says if we have a short run of trials, if I just roll a dice twice, there's a lot of variation on my results. I could land on 2 both times. I roll the die, I get a 2. I just did. I roll a die, I get a 2. Again, and all of a sudden you're like, well, it looks like 2 is very, very likely to occur. However, if I continue to roll the die time and time again, what I would find is the amount of times that I've rolled a 2 would end up being 16.7% of the total amount of times that I've rolled. Okay? This is kind of shown here with this simulation. This is a simulation of a bunch of coin tosses. 1 coin toss, 5 coin tosses, 10, 50, 100, 500, and 1,000. Okay? The first coin toss was a head. Second coin toss seems to be a tail. And what you'll see is that you might get a bunch of heads in a row and then a tail. That doesn't mean that the probability of flipping a head is going to be higher than a tail, because as we continue to flip that coin, we will see we will get closer and closer to this 50%. Okay? And we are going to show that using this die and using the 2. So everybody's got a die, right? Good. How many of us are we? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So every time we roll the dice once, we do 24 trials. Okay? So the probability of rolling a 2 is still 16.67%. I want everybody to pick up their die. And I want you to just do this once and be honest. I want you to roll the die right now. Raise your hand if you got a 2. 1, 2, 3, 4, 5 of us out of 24 of us got a 2. What is that percentage? 0.208. Right now, we are a lucky class. We have gotten more 2s than the theory is kind of telling us. But let's all roll a 2, the die again. Be honest. Ready, set, roll. Raise your hand if you got a 2. 1, 2, 3 of us. Okay, so now if 3 of us got a 2, that's a total of how many successful 2s thrown? Yeah, total. 8. How many total trials have we had? 48, right? Because everybody's rolling it twice. What's 8 divided by 48? 0.16. Unbelievable. All of a sudden, we went from a lucky class to we're about average class. Do we want to do it again, see if we can get back onto the lucky side? Okay, ready, set, roll your die. Raise your hand if you got a 2. 1, 2, 3, 4 of us. We went from 8 to 12 out of 72. What is that percentage? 16.7. Oh my goodness, we're super average. Now what you'll find is if we did this some more, we might have blips up or blips down. Let's do it again. Let's do it again. I feel like this is going to be the time that we're going to get like 10 twos. Ready? 1, 2, 3, roll. Raise your hand if you got a 2. 4 of us again. So no, what you'll find out is that, maybe we'll have blips up or down, but 72 plus 24 is 96. In the end, as we continue to roll more and more times, our class is going to be, this is exactly on the theoretical probability, okay? That's the cool thing about probability. That's kind of what Vegas wants you not to know. Vegas always has a little bit of an edge on the player. They want you to play for as long as possible, which is why it's a cool environment, why they give you free drinks when you go to Vegas, stuff like that. They want you to stay at the table and keep playing because eventually, if you had a blip up of luck, that luck will probably end up being gone and you're back to being just an average person, okay? Instead of staying at the table for a long time, you should probably just bet once, win, and leave. And that's just probably as best as you can do. Of course, that's not true. I mean, people sometimes, make it big, but law of averages say eventually that you're going to be average, okay?
Did you buy a lottery ticket?
Did I buy a lottery ticket? No.
Yeah.
It's pretty big now, right? Is that the whole thing? It's a lot. I'm due, right?
Yeah.
Right.
Yeah.
Right.
I could do it.
Okay,
Yeah.
so that's cool about probability. Eventually, we all end up average when we're talking about things. Now, the important thing about probability is the sample space. The sample space is the bottom of our probability. So the sample space is where we get our total possibilities. Okay? This is how we calculate how many total outcomes we could have for a given situation. And there's really 3 different ways that we could list off our sample spaces. And back when you were in elementary school, you would list all of the possibilities in a systematic method. And you might even do that now for certain questions that you kind of have to. There are tree diagrams that you probably did in middle school. I'm going to hopefully teach you the multiplication principle, which is what you'll do now to calculate total outcomes, the total outcomes that we could have. And the multiplication principle is used when we're doing more than one thing, okay? So for more than one thing. If a task can be done in A number of ways and a second task can be done in B number of ways, then both tasks can be done in A times B number of ways. Example, and this is what I kind of do. And we're not going to get into probability rules. We're just going to talk about total outcomes. We're just going to right now talk about the bottom of our formula up here for probability. The total number of outcomes. The total number of outcomes comes from my sample space. For example, total possibilities if I flip a coin twice. Okay, I flip a coin twice. What are the outcomes that I could have? Give me an example of an outcome. I flip a coin, I get what? And then I flip a coin again and I get what? Tails, heads. That's a possibility, okay? That's one of my possibilities in my sample space. What are the others? Well, I could flip a coin and get heads, flip it again and get heads. That's another outcome. I could flip the coin and get tails twice, right? T then a T. That's a possibility. So what we could do is Back in elementary school, we used to say, oh, I could get heads, then heads. I could get heads, then tails. I could get tails, then heads, or I could get tails and tails. And all of a sudden I say, okay, the total possibilities, or the bottom of my probability of getting certain outcomes if I flip my coin twice would be 4. Okay? But the multiplication method makes it easier. This is the elementary method. If I use the multiplication method, I say, what are the possibilities for my first trial? Multiply that by the possibilities of my second trial. My first trial, I have a heads or a tails. 2 possible outcomes. My second trial, I have a heads or a tails. 2 possible outcomes. Multiply 2 times 2 and you get a 4. Now you might say, well, elementary method is just as effective and as fast as this multiplication method. But what happens if I flip the coin 3 times? Or if I flip the coin 4 times in a row? All of a sudden, it becomes much, much more difficult to list them out this way. So let's say I flip the coin 4 times. Let's think about certain possibilities. I could have heads, 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 heads. I could have a tail here, a tail here, a tail here, a tail here. That covers all of my 1 tails. I could have 2 tails, 2 tails, 2 tails, 2 tails, 2 tails. It covers all of my 2 tails. I could have 3 tails, 3 tails, 3 tails, 3 tails. Okay? See how all of a sudden that becomes more difficult to do. But if I flip the coin 4 times and I just use the multiplication rule, I say, well, I have 2 possibilities for my first flip, 2 possibilities for my second flip, 2 for my third, and 2 for my fourth. 2 times 2 is 4, times 2 is 8, times 2 is 16. That means if I flip a coin 4 times in a row, we'll have 16 total possibilities. Okay? That's the same thing as almost like rolling a die and getting odds or evens. Okay? And I want us to do that, actually. Let's see if we can cover everything. So I want you to say that evens is heads and odds is tails. I want you to roll your die 4 times and see what you got if you flip the coin 4 times. Ready, set, go. Write it down on a piece of paper.
No, 4 times?
4 times. Now, my guess is, because we have 24 of us, that we're going to cover pretty much every single possible trial in this. Okay? So did anybody get 4 heads in a row? There you go. There's 1 person. Check. Anybody got 3 heads and a tail? There we go. 2 people. That doesn't bode well, but I like it. Anybody get 2 heads, a tail, and a head? 2 heads, a tail, and a head. Anybody get a head, a tail, and 2 heads? Oh, we missed. Anybody get a tail and then 3 heads? We missed on that one too. Anybody get, let's do head, head, tail, tail. Anybody get head, head, tail, tail? Yes, in that sequence. Boom, got it. Anybody get head, tail, head, tail? Oh, 3 of us. There goes why we got that. Anybody get tail, tail, head, head? There we go, there we go. Anybody get tail, head, tail, head? Look at this. This is incredible. Anybody get Did we cover all the possibles with 2s? Those. Good. Now we're on 3 tails. Anybody get head followed by 3 tails? Yep. That's awesome. Anybody get 3 tails and a head? Great. Anybody get a tail, a head, then 2 tails? Unbelievable. Anybody get a tail, a head, then a tail? Unbelievable. Anybody get a head followed by 3 tails? Oh, there's the miss. How many possibilities do we have? Did we cover anything? Oh, we need to do all the tails. Did anybody get all tails? Nobody got all tails?
We already did the head.
Oh, yeah, look at that. Okay, never mind. Yeah. Did anybody get a head then 3 tails?
No.
So maybe we didn't. Have we listed all 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We're missing 2 more. What are the ones that I'm missing? Did anybody see theirs not up here? Well, you guys can see too, right? We have all the 1 tail. We all have the 2 tails. Oh, I don't have the outside 2 tails. Anybody get a tail? 2 heads and a tail? No. And there's probably 2 more. But what I'm just kind of showing you is that, if we have enough trials, we'll cover all of these. Each of these trials, possibilities, there's a 1/16th shot at getting them. There's a 1/16th shot at getting 4 heads. There's a 1/16th shot at getting 4 tails. Okay? That's because this is one of the possibilities in my sample space out of the total amount. Okay? 2 tails. 1, 2, 3, 4, 5, I believe. So 5 out of 16. Since we had enough people, we covered pretty much all of the possibilities. Everybody had a 1/16th shot of getting one of them, and you guys got so many of them that we almost covered the entire sample space, which is cool. Okay? So that's how we get the total outcomes kind of deal. 16 outcomes. Let's quickly do a couple examples of just the total outcomes. So go to the next page, go to 1A. Okay, I don't want you to define the sample space. It's going to take too long to do that. Instead, I want you to just write down how many total outcomes or possibilities can you have. And I'm going to give you 3 ways. The answers are scored either right, wrong, or O for omitted. So like an SAT when you used to be punished if you guessed, but no points are taken off if you didn't. Okay? How many outcomes could you have for all of the possibilities of 4-question quizzes where you have 3 choices? Go ahead and kind of write down what you think is the answer. Use your calculator to get the answer. Check with a neighbor. Seems like a lot, right?
So like the order does.
The order does matter, yes. Okay. The order does matter. The order matters, so like my first question, I could either have in my first question it graded as an R, a W, or an O. My second question can be graded that way. My third, that way. My fourth, that way. How many total outcomes?
And so, like, does it matter if you get right, wrong, 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 and then wrong, right, wrong, wrong?
That'd be a different possible outcome.
So, yeah.
So yes, that'd be a different outcome. So Mr. Riley asks, if I get one wrong, say I get the first question wrong, is that different than if I get the second question wrong? Yes, it's a different outcome. Okay, so that's why we saw getting two tails in different ways were different outcomes. Okay, how many outcomes? Well, for the first question, I could be right, wrong, or omitted. For the second question, I could be right, wrong, or omitted. For the third question, I could be right, wrong, or omitted. Fourth question, right, wrong, omitted. 3 times 3 times 3 times 3 is the answer. 3 to the 4th power. And what does that equal? 88? 81. Yep. Do you want to try to list all of those off? No, I don't. But if we roll a die, it'd be like 1, 2 being right, 3, 4 being wrong, and 5, 6 being omitted. And we could see that we'd get all these different possibilities, and probably nobody would share the same one, because there's 24 of us and there's 81 possibilities. Okay, so that's the idea. Go to 2A. And again, this is going to be going in the bottom of our probability. So if I wanted to find the probability of getting, all 4 right, I would have in the bottom 81. How many possibilities are there for me to get all 4 of the questions right? How many ways can I just get all 4 questions right? One way, just right. That's it. So the probability of getting all 4 right would be 1 out of 81 if I'm guessing and have those 3 options. Okay, maybe not a perfect example, but it's good. Number 2, if a family of 3 children, excluding multiple births, I don't know why we're talking about that. Okay, we could have we're trying to figure out the possible outcomes for boys and girls out of this 3-person family. Okay, the total possible outcomes for this 3-person family in terms of boys and girls. You guys figure out the total possible outcomes you could have for 3 kids in a family. And go ahead, order matters for all of these, unless it's told not to. And go ahead and write down, list off all of your outcomes. Find it using the multiplication method, and then go ahead and write them down just to check to make sure that you got the right answer. For example, maybe I do the possibilities first. I write them down first. Well, I could have all 3 boys. That's a possible outcome, right? Well, could I have 2 boys and 1 girl? That's another possible outcome. I should be able to write down all of these, but I also should be able to confirm that I have the correct amount by using that multiplication method like we did above. Go ahead and check your answers with a neighbor. I'm going to erase this so you can see. Talk about it with your neighbor. How many possible ways could you have 3 children in terms of gender? If you write them down one at a time and you've exhausted all of your options, well, then that's the amount of outcomes you could have. The key is we should be able to connect this multiplication method that we did before with the possible outcomes. Good. What do we get, Mr. Johnson? We get 8. If you start writing it out, you'll find you could have 3 boys, 2 boys and a girl, a boy then a girl then a boy, a girl then 2 boys. You'd have a boy then 2 girls. You could have a girl then a boy then a girl. You could have 2 girls and a boy, or you could have all 3 girls. Fingers crossed. That's it. That's the outcomes. Now, how could I find that using this numerical method, this multiplication method? Well, for the first child, they could be either a boy or a girl. That's 2 options, right? For the second child, they could be either a boy or a girl. How many options are that? 2. For the third child, there could be a boy or a girl. How many options are that? 2. So yes, there's 3 children, but each child only has 2 options for what they can be, which is why it's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Now we have this number corresponding with that number that we can see just by doing the systematic list. Now the systematic list is not very practical for most situations, okay? Because if I talked about 5 children, all of a sudden it would be 2 times 2 times 2 times 2 times 2. So we'd go from 8 to 16 to 32 possibilities. And it would take you forever, well, not forever, it would take you a long time to write down all 32 possibilities. So that's why the multiplication method is very, very smart. And all it is just how many possibilities for each one. So let's go to 3. And let's talk about 2 dice being tossed. Now, don't even look at this. This is the list. They listed it out for you. But think about 2 dice being tossed and about it almost being like the first dice is tossed and that is in the first slot, and then you roll the dice again and that number goes in the second slot, which means having a 1 then a 4 is different than rolling a 4 then a 1. Okay? They're different. Well, how many possibilities could I have for rolling 2 dice, knowing that 1 and 4 and 4 and 1 are different? You should be able to come up with this number without even looking at this using that multiplication method. I roll the first dice, I have how many possibilities? Then I roll the second dice, how many possibilities? Combine the 2, what are the total possibilities that I could have for rolling 2 dice? Write it down, talk to a neighbor. Confirm by counting up this list of all possibilities. But get the answer first. Write down a number first and then confirm. My first roll, my second roll, my total outcomes. How many outcomes could I have for my first roll? 6, right? Well, how many outcomes could I have for my second roll? 6. What's 6 times 6? 36. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's a total of 36 options right there. Okay? If you count them up, you get that. So, turns out, what started as very simple was the probability of rolling a 2, 1, 6, nailed it again, I'm on fire, becomes much more difficult if it's like, what is the probability of rolling a 2 in either of the die with 2 dice? Well, you have 36 possibilities, and I rolled a 2 again with that last one, but you got to count up all the possibilities of having a 2 in there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 out of 36. Okay, so it's actually a fairly high probability. What's 11 out of 36?
Did you do 5?
A little bit more than 30.
No, because that would be 25 possibilities. Okay, because of the whole, we'll have to talk about how you could have repeat things that you have to take them out.
Oh.
Kind of, not necessarily. That's kind of the not. But the easiest way to do one like that, a possible 2, is to really just count. I could have a 2, then a 1. I could have all of these with 2s. I could have a 2, 3, 2, 4, 2, 5, 2, 6, and that would cover all of them. Okay. But the most important thing that we're talking about right now is just the total amount of outcomes. This would go in the denominator for all of your probability questions right here. Let's go to number 4. Let's skip number 4, actually. We'll get into experimental versus theoretical in the future. Number 5, I have a jar with 6 red marbles and 4 blue ones. How many possibilities do you have? Well, you can say, oh, I could pick up a red marble or I could pick up a blue marble. But let's say each marble was like labeled individually. How many total marbles do you have in the jar? It'd be 10. 10 is your total. Okay? So total number of outcomes. Number 6. Number 6 is going to be one of the multiplication things to find the outcomes. Okay? Suppose you are taking a 25 question multiple choice quiz in which each problem has 4 answer choices. Let's just make that a 5 question quiz with each problem has 4 answer choices. How many possible ways can you answer that 5 question quiz with the 4 answer choices? A, B, C, or D. Write that down on the side here. You can do A, B, C, or D for the first one, right? So those are your first 4 possibilities. For the second question, you can answer it A, B, C, or D, right? Boom. 4 for the second question. 4 for the third question. For the fourth, for the fifth, it would be 4 times 4 times 4 times 4 times 4. Those are all the possible ways you can answer a 4-question quiz. What is that? A big number, right? What is it equal to? 1,024. There's 1,024 options. Just for 5 questions. Don't guess. Most likely your outcome is wrong. If you guess completely, you have a 1,024% chance, or 1 in 1% chance that you're going to get it right. Okay? Okay, so that covers the bottom parts of probability. The total possibility is done. Now, the number of successes or the number of outcomes of the event, it all depends. There are different ways to kind of go with that. You can either just count. So let's go to 1B. It asks us to list the outcomes in the event consisting of getting exactly one question right. Well, if I get one question right, it would be right. Let's go back to just right, wrong, or right or wrong. It'd be right and then 3 wrong, or 1 wrong, then a right, or the right as the third question, or the right as the fourth question. So here is a way how we can kind of count our successes. And now we're talking about the top part, the number of successes. Put them together, the number of successes and the number of total outcomes, and you'll find the probability. Okay, now this is different because there's more than these. If I went back and I changed this to how it was just originally going to be, the right and wrong, the total amount of outcomes would be just 2 times 2 times 2 times 2. So if I just kind of cross it out for here. So 2, 4, 8, 16. Okay. What is the probability of getting one question right? Here are the amount of successes I could have, 4 out of my total. That's probability. This is 1/4, sure, or 25%. Okay? Part C is another way how you can count your successes. You list the outcomes of the event consisting of getting all 4 questions right or wrong. Well, if I got all 4 right, it would look like this. If I got all 4 wrong, it would look like that. How many successes do I have, or how many things that I'm looking for do I have? Just 2. This is 2 under the 16. Or if you use the right, wrong, and omitted, it'd be 2 right out of 81. I don't want you to be confused by that. Let's just stick with just right or wrong, 16 possible. So that's equal to 1/8, or what's that equal to? 12.5%. Okay? We'll skip D, we'll come back to D. Okay, let's look at 2B. And C. This is the same kind of thing where you're going to just kind of list and count your successes. It's the easiest way to do B and C. Go ahead and find the probability of having 2 girls and a boy in that order. And then find the probability of having 2 girls and a boy in any order. Compare your answers with a neighbor. Let's see what we get. Mr. Funk, it's day 1. You're not starting off on a good foot here. Okay? Let's keep our phone away. Let's understand where we are in the notes. Cool? Cool. We're doing B and C for number 2. Already done it. Look at you. All right, good. Make sure your answers are correct. What's up? What are you going to bet me? I don't. Okay. How about you just check your answers with your neighbors, and then it's going to be all right. Great. Okay, check with your neighbors. Make sure you got it right. I don't see everybody checking.
was done, you know, and I knew that we had already talked about it.
Did you?
Yeah.
Yeah?
I did before you even said it.
That's also true.
All right, good. I'll call on you then, Miss Janison, in the future. No? Okay. We're still working on it. Good. Part B. How many possibilities can I have with having just two boys and two girls and a boy in that order? Just one. G, G, then a B. That's it. That's one possibility out of a total of 8 possibilities. What's that percentage? 12.5%. All right, Mr. Funk, what is the probability of having two girls and a boy in any order? 3/8 is correct. We have 3 possibilities of having two boys and, two girls and a boy. 2 girls and a boy. 2 girls and a boy. 2 girls and a boy. Those are my 3 successes out of 8 total possibilities. What's that as a percentage? Anybody do it?
37.5.
Thank you. 37.5%. Good. Okay. Let's go to 3C, D, E, and F. All of these are really the same, where you're going to list and count your successes and put it over your total outcomes. When you're done, check your answers with a neighbor. No, less than 5. No, 36 are the total possible outcomes of rolling 2 die. Doesn't mean there's 36 sums. Those are just the outcomes. No, that's good. That's perfect. That's right. 6 out of 36 for C. Check with your neighbors. 4 questions, all involving just counting. 0 could be an answer for probability. Probability can be between 0 and 1, including 0 and 1. All it is counting. You just got to figure out how many total possibilities you could have. Do we need more time? Okay, another minute or so. We got to get to the other important rules about probability that doesn't involve counting. Okay. Probability of having a sum of 7. Miss Pushman. 6 out of 36. We got 6 and 1, 5 and 2, 4 and 3, 3 and 4, 2 and 5, 1 and 6. Any questions about that? What's that percentage? 16.67. Okay, good. Any questions about that? Okay. Part D, sum less than 5. We got 1, 1, 2, 1, 3, 1, 1, 2, 2, 2, and 1, 3. That's 1, 2, 3, 4, 5, 6 out of 36 as well. Sum equal to 13. Or none, there's 0 successes, right? So you'd have 0 successes out of 36 outcomes. What's that? 0%. There's no chance you will ever roll 2 die and have the sum equal 13. Okay, now, going to part F. If we have an or statement, look at the front page really quickly. If we have an or statement, instead of just counting up kind of both of them all together, we can count them individually and just add the probabilities together. It's essentially what you did. The probability of the first one being a success plus the probability of the second one being a success. So I got 7, which is 6 out of 36, plus how many possibilities do we have to roll an 11? Just 2. And that's how you can get 8 out of 36, which might be a little bit easier. Is that what, a quarter? No, that's not a quarter. What is that equal to? What is it?
It's just 22.2.
22.2%. Okay, questions about that? Okay. Well, there's another rule that's going to help us that deals with multiplication. Multiplication helps us deal with the amount of outcomes. Multiplication will help us find the probability of 2 events occurring at the same time. Go back to the first page. Notice this rule. If we want to find the probability of an and statement, the probability that I roll a 2 for my first one and then I roll a 3 for my second roll. Okay? What would we do? We would multiply the probability of rolling a 2 for the first roll. What's that probability? 1/6, right? So far, so good. Well, I would have to multiply that by the probability of rolling a 3 on the second roll. What's the probability of rolling a 3 on the second roll? Another 1/6, right? So rolling a 2 and then a 3, I have a 1 out of 36 chance to do it. I've rolled a 2. Everybody try. So let me just say that. If I, as an example, probability of rolling a 2, then a 3, it's the same as probability of rolling a 2 and then a 3, would be equal to the probability of rolling a 2, which is 1/6, times the probability of rolling a 3, which is 1/6, so that's 1/36. Okay? Everybody pick up your die. There's only 24 of us, so I don't think we're going to roll it. I think maybe we'll roll it once or twice out of the first 2 tries. Okay? Pick up your die. Everybody, ready, set, roll your first die. Who got a 2? Okay, you guys get to roll again. Ready? You're looking for a 3. Set, roll. I got a 6. Anybody get a 3? Boom, we have a winner. Okay? Now, let's all do it again. Let's see if we can roll a 2, then a 3. Ready? Set, roll. Mr. Funks, you get a 1 again?
I didn't. You told us to stop.
No, we're all rolling again. Keep your phone away, dude.
Well,
Yeah, you're not paying attention. Anybody roll 2? Good. You guys get to roll again. Mr. Visser, you're going to go 2 in a row. It's like a lucky day. Ready, set, roll. Anybody get a 3? We got 1 out of 48 tries, which is closer to the 1 out of 36, okay? Hold on, let me finish. We got to finish a couple problems and then I'll let you go to the study hall. Okay. So let's go back to 1D. 1D. If I have an OR statement, you would add your successes together. You can add your probabilities together. So look at this OR statement. Probability of B or C occurring. You would add the probability of B and the probability of C occurring. And that would give you your answer. Go to part B of number 3. What is the probability of getting 2 even numbers? So that's an even for the first roll, then an even for a second roll. What is the probability of me getting an even on my first roll? How many evens are there on a die? How many total numbers are there on a die? So there you go. The probability of rolling an even is 3/6. What's the probability of me throwing an even on my second roll? 3/6. Again, you can multiply those two probabilities. Probability of even times the probability of even, and that would give us the probability of 2 even numbers. That's 1/2 times 1/2, that's 1/4, which is 0.25 or 25%. Go down to 5A. This is another one of those multiple probabilities occurring. I have 6 red marbles and 4 blue ones, meaning I have 10 total marbles in a bag. What is the probability that you draw 2 red marbles in a row if you put the first one back? So I have in my hat over here 6 red die and 4 green die. I reach into my hat. What is the probability that I pull out a red die? I did. What is the probability? Is it 100%? No. What's the probability? How many? 36 over 100 is correct. Exactly. How'd you get that? You just did it in your head? Well, how'd you get 36? No, it's fine. Just tell me how you got it.
Well, you add it up every time. You add 6 up, 6 out of 10, 6 out of 10, and then you add up.
Kind of. The 6 out of 10 is correct.
If you draw it 6 times, or however many times you're drawing it, 6 out of 10. I don't know how I got it, actually. I don't know how I got it.
36 out of 100 actually isn't correct. Actually, if you simplify that, that's not the answer.
Well, my answer that I got was 9 over 25 is what I simplified it to.
That's right. Your 36 out of 100 is correct for the final answer. I'm just talking about what is the probability that I draw 1 red die out of this hat. 60%, right? You have 6 reds out of a total of 10 die, okay? So that's the probability of rolling or pulling out a red. Now, if I do it twice, 6 out of 10 for the first one, put it back in, I have 10 total die, 6 are red, 6 out of 10 chance of the second one. So that's how you can calculate this probability.
Oh, 6 times 6 and then 10 times 10. That's right.
That's how you did it. Good. So it's the probability of a red times the probability of a red, which is 6 out of 10 times 6 out of 10, which gives us 36 out of 100, which is 36%. Okay? This is the whole multiplication of probabilities. If I came around with my hat and had you all select it, I would say only 36% of you would get this right, or get 2 reds in a row. Now, this is a different question. If I have these 10 marbles, or these 10 die, and I pick up the first one and it's a red one, and I don't put it back in the hat, find the probability for parts B. Go ahead. So I have the probability of picking up a first red, and then I have to pick up a second red. Okay, write down the probability, check with your neighbor, see what we get. Ms. Jameson, explain to us your answer, how you got it.
Okay, so you took the red out, so you are only left with 5 red marbles, and then you only have a total of 9 in the beanie. That's how I got my answer, 55.
That is correct. You have the probability of the first red, which is 6 possible reds out of a total of 10. But when you take out that first red, you only have 5 reds left over at a total of 9 marbles. So you would take that 6/10 and multiply it by the 5/9, and you'd get 30/90, which is 1/3. Is that what you got? I'm not sure if that's what you got. 33.3%. Good. Okay, finally, 6A and B, last two. We're taking a 25-question multiple choice test. We turned it just into 5 questions, right? If I guess on the first 3 questions, what is the probability of missing the first 2 but getting the third one correct? Check your answer with a neighbor. I have kind of help right there. Perfect. Good job. Think about the probability of getting it wrong. Probability of getting it wrong times the probability of getting it right. What is the probability that you're going to get it wrong if you have a four options on a question? 3 out of 4, exactly. 3 are wrong, 1 is right. If I get it wrong, I have a 3/4 chance of getting it wrong. I get the second one wrong. Well, I have a 3/4 chance of getting the second question wrong, because one of the options is right, the other 3 are wrong. But then I get the last question right. Well, I selected the correct one answer out of the 4 possibilities, 1 out of 4, multiply those 3 together, and that's your probability of getting the first 2 wrong and the third correct. 16 times 4, what is that, 64? 9 out of 64. And what's that percentage, Ms. Simpson?
14%.
14%. If you guessed on the last 4 questions, what is the probability of getting the first 2 correct and the last 2 incorrect? Use the part A as an example to do part B. You get the first 2 correct, you get the last 2 incorrect. Let's see this for a second. Okay. Correct. I have a 1 success out of 4. 1 success out of 4. If I miss it, I have 3 possibilities that would be wrong out of 4. 3 possibilities that are wrong out of 4. 9 out of, what is 64 times 4? 136? 256? Whoa, way off. What is that as a percentage? 3.5. Okay, I wanted to do one little thing just for my own amusement. Go back to this problem A. This answer, make sure we have this answer correct. 9 out of 256 or 3.5%. We're guessing on 3 questions. We found out that the probability was 14% for you to get the first 2 wrong and the last one correct. I want you to write down 3 guessing answers, A, B, C, or D, on a paper. Okay? So like pretend like you're guessing on a quiz and you're guessing the first 3 questions. So guess A, B, C, or D 3 times. Do you understand? So we're just like guessing on a quiz.
3 times.
3 guesses. A, B, C, or D 3 times. Yep. Odds are 14% of you are going to have the same 3 answers that I do. Okay? Now, if there's 24 of us, 14% of us is like 3 from what I calculated. I get the answers are D, D, A. Anybody get D, D, A? 0? All right, you guys are unlucky. That's all. Let's do it again. I bet you we can get 3 or 4 of you will get it right. I want you to guess on 3 questions. I just want you to write 3 letters in a row, A, B, C, or D. A, B, C, or D, A, B, C, or D, A, B, C, or D. Odds are probably around 3 to 4 of you will get this same answer as I get. Ready? B, D, C. You had that the first time? Actually, no, I was actually wrong. You don't want to get the exact same right. You want to get the first 2 wrong and the same as the third one. That was my bad. Did anybody get the first 2 wrong but got a C for the last one? 4 people. That's beautiful. Good, good. Sorry, I totally mistook what I was doing. Okay, the first 2 were wrong, the third was correct. Boom. All right. Anyways, that was just for my amusement. Your homework is a worksheet and then 3 book problems. The book problems can go on the worksheets. We will do the back page of this worksheet as practice before our quiz. Yes.
I left my laptop in my last class.
Sure.
Can I use it?
Sure. Thanks for paying attention into study hall time. No, I said there's additional questions from the book. Yeah, not just only do the front side. Everybody write these additional questions on your paper, 7.4, 13, and 18. You can do it on that paper. 7.4, 13, and 18.
I have friends in that class and we need to work on project. I don't know where or some board.
There you go. Mm-hmm. I would work on your homework in class. If anybody needs a book to do the book problems, they don't know where their book is at home or something, the books are up here.